Hello all, welcome back to my YouTube channel. So guys, this is video 7 of our machine learning playlist, and in this particular video we will be discussing about some of the feature scaling techniques which are standardization, normalization and min-max scalar and robust scalar. So guess what guys, in this particular video not only the theoretical, I'll be also taking a data set and we'll be executing a code. In the coding point of view also we'll be executing each and everything, and we'll be seeing the difference between all this which can perform better. So then what are you all waiting for? Subscribe the channel and also share this video with your friends, those who are learning machine learning, and it will be helpful for them also and for me also. So guys, now let's not waste our time. Let's dive into our computer screen and discuss more about this particular topic. So guys, this is the article at where I have written all the theoretical part so that it will be easy for you all to remember, and you don't need to note down anywhere or create a notes on this, so that you can, whenever you want, you can refer this article directly. Just listen and understand this video completely. It's enough of this particular topics. Before this, video 6 was released, in which I have explained you all about feature scaling. If you have not watched that, kindly check out that video, because this is the continuation video of that particular topic where you will be understanding the concepts better. So data is rarely perfect, and it is often comes with various shapes, forms, and even various different ranges, etc. So what our machine learning can do, because in machine learning, if the data is not scaled properly, the training accuracy will be very bad, and also it cannot even train properly. The model will be very worse. So we use feature scaling techniques. So now let us discuss one after another feature scaling techniques. So the first technique is nothing but standardization. Standardization is also known as Z scoring, which is nothing but zero mean scaling. It is a common method used in data pre-processing for scaling or centering the features in machine learning. So this is a normal method which we use when it comes to standardization, so that we can scale our data or standardize the data. So standardization doesn't scale the data in range of 0 to 1. Instead, it scales the data to have a mean of 0 and standard deviation of 1. So understand this line properly guys. So let me show you all mathematically here. So you can see this is the formula to standardize the data. Z-score will internally use this particular formula. See, x negation is equals to x minus mean of x. So x is nothing but your data, whatever data you have, that is your x, and minus mean of x. What is the mean of that particular x? And divided by standard deviation of that particular x. So this is what, if you perform this calculation, you will get x negation. So this is the formula to perform that. For example, if you have x as 10, value as 10, then you have to find out the mean of that particular value, and you have to divide that with the standard deviation to get the negation of that particular value. You can see here x is your original feature, x negation is your scaled feature, mean x represents the mean average of the data point features, and standard deviation represents the standard deviation of all the data points. So explanation is here. You can have a look on this detailed explanation, calculating the mean and how you are going to divide and etc. Everything is here. So you might have doubt about where you need to use the standardization technique. Standardization is beneficial when you have the data that vary, spreads, and want to make it suitable for machine learning. Means that's varying and it has more spreads. That comes, like I told you all right, when you have more spreads in the data and you want the data to be standardized, and you don't want the data to have more sparsity, then you can use this. The standardized value can have both positive and negative values also, and the specific range depending upon the characteristics of the original data. So here is an example. You can have a look on this. So this is a normal data. M is equals to 10 and S is equals to 30, and you have this features. Now this features, what it happens, you can see here it is very large, and you can see the standard deviation of it. So once you have standardized this, then you can see here its features, and it has been scaled between 0 to -4 here. Same here also, 0 to -4. So it is varying. Sometimes it will come between -4 to +4, -1 to +1. It's all depending upon the data. So this image actually we got it from Google only, but no problem. We'll be practically implementing now, right? So you will be understanding that better. So practical implementation using official sklearn.preprocessing standard scalar library. So I'm not going that mathematically here because you can have a look on this to find out the mean and etc. I'm not going that mathematically because you need to understand in the coding point of view mainly, and mathematically you can take some number and you can perform calculation of it. Let's take example of 10. So perform mean and standard deviation of that and let me know in the comment. So this is the code which I have already written so that we don't need to make this video more lengthier of typing the code. So I have already written the code so that we can execute fast and I can explain you all because there are many topics to be covered here. Feature scaling. So for feature scaling, what we have to do, firstly we have to import the necessary libraries here. So we require pandas, numpy, matplotlib and seaborn. So about pandas and numpy I have already created a separate tutorial where you will be learning everything about pandas and numpy. You can have a look on those videos also. Those video links are in the description or it will be available in my channel. Load the dataset from seaborn. So in SNS or else you can say in seaborn there is an inbuilt dataset called tips. So we will be using that inbuilt dataset to perform standardization now. First let me run this cell. Yeah, run away. Yeah. And finally we will be loading the dataset called tips, and you can see here the dataset head total bill, how much is the total bill and what is the tip and what is the gender of that particular guy and whether he is a smoker or day when it was and time and size. That's all. So here we are talking about the tips.csv and I'm not considering any categorical columns, and let us consider smoker as an output column. So you can see here tips is our main requirement and smoker is our main requirement. So we'll be using only them. So we will be dropping the rest columns, and let me run that code for you all. Now you can see here after dropping that total bill, tips and gender, smoker and size. Okay, so here what happened, you can see here only this gender, whatever gender it was, and this particular day is not required to us because we are just standardizing it, right? We don't require that, and time also we don't require. So we have just dropped this both, and this smoker and sex, these both are in numerical I mean in categorical format, which is nothing but in strings. You can say as it as in strings. So what we have done here, df.smoker.replace no with 0 and yes with 1. This is a kind of binary classification. So we have done simply like just encoding it with binary for features like 0 and 1. Actually we have another different methods like label encoder, ordinal encoder. I'll be teaching you all about that in the upcoming videos. But here for now let us take 0 and 1. Only two features are there, right? So we'll be taking 0 and 1. And for female as 1 and male as 0. So I have run this, you can see here. Now split the data into train test split. From sklearn.model selection import train test split. We'll be using this, and here we have already written in a comments for you all so that you can understand why we are doing train test split and what is the main use of it. So x train, y train, x test, y test and train test split is equal to df.drop column smoker axis 1 and df of smoker, and then test size is nothing but 0.3, which is nothing but 30% of the data we are giving to test. And here train x train, x test and y train, y test, these are nothing but train data is to train the data, and y train is also, this is nothing but our output column. Smoker is available in y, y is nothing but the target value, and x test and y test are nothing but these are your kind of, you can say, for testing or for validation. Once you have done the model training, then you have to validate, right? So we will be splitting for that also. And here df dot drop column smoker. So this is for X train. We are taking X train, so we have dropped that column smoker because that's our target feature and we don't require. And finally df of smoker is our main target feature, so we are just taking target feature for Y. So let me run this. Now you can see here shape of 170, 4 and 74, 4. So at here we have 74 features in Y. No, sorry, X test. So X test shape is of 74 and X train shape is of 170. Now what we will be doing? So basic features are done. Now we will be standardizing the data. Apply standardization. So from sklearn.preprocessing you have an inbuilt library standard scalar. So we'll be using that. So scalar is equal to standard scalar. We have called that. Then the columns which we want to scale it out, we are just selecting column to scale. We are just storing them in a variable called columns to scale, and total bill and tips we are adding inside that. Now what we are doing, xtrain scaled is equals to xtrain dot copy. So create a copy to avoid modifying the original data frame changes. We are just creating a copy. This is optional. If you are sure about it, you can directly like standardize without creating any copy. Normally when you are at the fresher or when you are at the beginner, when you are doing, so that you don't lose your original data, we will be normally creating a copy. So from this again we are taking and we are now making it as a fit transform. We are fit transforming, applying the scaling to it, to this particular column to be scaled, and transform the test data also. So once training data is done, so for the X test also we have done the same. We have created a copy and we have applied scaling to it. We run this. It's done here. Now you see scalar dot mean. So array, which is nothing but the mean of that particular data, you can see here. And xtrain scaled is equals to pd dot data frame xtrain scaled comma column is equals to xtrain dot column. So this is nothing but this is getting storing in the scaled one. If you can see here, now xtrain, you can see here it is of normal xtrain. Before applying the standard scaling, this is available here, and after applying the standard scaling, you can see here the difference. So before applying standard scaling, it was 24 to, you can see all the values, because there is some kind of sparsity also. Some of them are high values like 32. So you can see here in tips and etc, 32, 26, 25, it's a kind of high sparsity. So there is a chance of taking more training. After applying the standard scaling, you can see here like it has got even some minus features and plus. Everything is between 0 and 1. 0 and yeah, -1 and 1. It's, you have the -1 value, right? So -1 and 1. So this is the main advantage of doing standard scaling. Now np.round describe xtrain.describe comma 1. So without using this round method, if you directly run, you will be seeing some negative values and etc. So what we will be doing, we will be using round to round off and show us the proper value. So this is before standardization, this particular describe method. So your minimum value is 3.1, 1.0, 1.0, and maximum value is 48, and you can see the count 170. Mean, you can see mean 19.6, standard deviation is 8.7. If you just run xtrain.describe or else df.describe, you will get your standard deviation and mean, so you can easily perform the calculation. Now let's take an example here. So let me perform like whatever this formula was here, right? Let me just run this for you and show. X minus mean divided by standard deviation, which is nothing but, if you go here, x1 is equals to, let us take the x value as maximum value. Here you can see here maximum value is 48.3. So what we'll do, we'll take, or else we'll take with a small calculation for tips we'll do. So for this what I'll do, 9 is your x value minus mean. What is the mean? Mean of x, you can see the mean of x here, 3. 9 minus 3 divided by standard deviation of that particular x value. So if you go for standard deviation, which is nothing but 1.3. Now if I run this, you can see here it's done. Now if I see the x value, x1 value, we have stored it in x1, right, which is nothing but a x negation. So this is your standardized value. After performing standardization, or else you can say standard scalar scaling, so this is your value. When you perform for one feature is 9, you get the standard scalar of 6.69, so on. Okay, you're getting my point. Like this, it performs in all the features, or else all the rows whatever is available in that particular column. I hope you got this. So again, we have done this after standard deviation. Also we have done this here. You can see here, after standard deviation, mean is 0 for this both, and you can see here all the topics. So these are after standard deviation. You can see, if you describe, you can see everything detailedly here. Now effects of scaling, graphical representation. So before scaling, you can see here, somewhere here the points are there, here, and you can see it's between 10 and 50. Now after scaling, what it happened, it lies between 5 and 3. So the scaling, what it has done, it has reduced the features and brought into a one scale of line, so that one scale of numbers, so that we can use it further. So this is the scatter comparison between tips and total bill. Okay, so this is just a scatter comparison. For that, this is the code. You can execute this and see now also. We'll get the same output only, because the code is already written, so you don't see that I'm making any mistakes anywhere. But when you are trying to write the code, you will definitely make the mistakes, don't worry, but try to solve it out. And you can use this same structure, nothing but you will be just changing the features and etc, nothing else. Take this code as your structure overview and try to perform in some data set. The above graph is a scalar comparison between tips and total tips before and after standardization. So before scaling, you can see here, and after scaling, in a sense after standard scaling. Before scaling, between 0 to 10, the features volume you can see, and even you can see this particular graph here. And after scaling, you can see both are equal and both are in a straight line. You can get a proper visualization here if you try to understand here of tips. Comparison of distributions, you can even perform some comparisons also, and you can see here this is a kind of right skewed. First graph is a kind of right skewed. When you apply standard deviation, it brings them to the center. You can see here, right at the right skewed, you can see here kind of, and you can see that there is a more kind of data here. It's not proper yet. When you after applying the standard deviation or standard scalar, you can see this a proper method. Now let us run this also, comparison distribution. You can see a total bills distributed before scaling and total bills distributed after scaling. So you can see the features like density and the total bill. You can see the amount, etc. So I would recommend you all, now by now you might have got how it is to be done, and same for tips before scaling and after scaling. You can see here, you cannot see the graph changes a bit here because these all are kind of properly scaled and there is no much sparsity in the data, so you cannot see that much impact. But you can see here the feature columns are changed, like this numbers or terms are changed. So now finally what we are doing, we are just performing from performing the model training here. Once you perform model training, you can see here 0.5 and scaled is equals to 0.55, 55%. Scaled and actual is 0.5. So I have done this in a small data set, right? So you cannot see that much of improvement, but when you perform it by yourself, you will see more improvement here. So we have used a decision tree classifier. So from decision tree classifier, and we have taken the metrics like accuracy score, and we have performed this. So first we have taken the decision tree classifier here, and for scaled also we have taken that, and we have fed that with data with that particular algorithm, which is nothing but we are feeding the data to the algorithm, training the data, and we made some predictions, make predictions we have done here, and we have tested that. After making the predictions with the y test, we have made predictions here, and finally we have checked the accuracy and scaled accuracy of both. That's all. You can see it's very less improvement because it's a very small data set and it's an inbuilt data set. Take your own data set from Kaggle or somewhere and try out, you will understand a bit more better. So this explanations, if you see, you will get it, and this is the coding point of it. Now when it comes to normalization, guys, I guess this video within I explain the coding point of view, it became a bit more long. So let's do one thing. I'll stop this video to here and I'll make a part 2 video of this particular normalization technique, where we'll be discussing about the normalization and left out techniques and all. We'll be performing coding there. Okay. So guys, that's all for today's video, and this continuation video you will be getting it out within another 2 or 3 days. Don't worry. Okay. So that's all for today's video. Do like, share and subscribe the channel. Thank you all. Bye bye.